Now let's talk about the limits and continuity on an interval. So, interval naman ang pinapatunayan natin ngayon. So, kung halimbawa may isang graph, no? There is a graph here. You are going to identify kung hanggang saan continuous yung graph. Okay? Yun ang sinasabi ng interval. So, we're referring to the set of x values wherein the function is proven to be continuous on this set or interval. Now we have the two conditions. A function f is said to be continuous from the left of a. Okay, I use a here. That indicates in the real number line. So if this is a, left ng a daw, okay, continuous yung function doon. Kung mapapatunayan mo na yung f of a by evaluation ay equals the limit of f of x as x approaches a from the left. So take a look into the partnership left and then the symbol left there. Okay. Now in the second condition, a function f is said to be continuous from the right of a if and only if f of a is equal to the limit of f of x as x approaches a from its right. Okay. Now obserbahan natin yung first example. Sabi dito, the function f is defined by f of x, which is defined by f of x is equal to square root of x minus 2, is continuous at from the right of x that is equal to 2, but not from the left at x that is equal to 2. The reason, because since f is undefined at x that is less than 2, the domain of this function is a set of all real numbers, greater than or equal to 2. So if you're going to use the rule suggested, the condition suggested there, let's try to make use of right casitos on the second. What is f of 2? So f of 2 here is square root of 2 minus 2. That is 0. What is the limit? Okay, the second, we have to compare them kasi. What is the limit of the square root of x minus 2 as x approaches to from the right, because we're proving it right, kung continuous siya sa right. And we can see here immediately, that when you keep on increasing, decreasing the numbers, because you are approaching 2, it will happen that square root of x minus 2 will keep on approaching 0. The limit is 0. Now, if you compare them, since 0 is equal to 0, making it true that f of a should be equal to the limit of f of x as x approaches a from the left. Dahil napatunayan natin yan. Totoo nga na continuous siya at the right of x that is equal to 2. Okay? In number 2 naman, we can see that g of x that is equal to 1 over x, is continuous from the right. Okay? From the right, but there is a condition on the left here. From the right of x that is equal to 1. Bakit? Kasi if you check the graph of this, a quick graph of this, ito yung itsura ng graph niya, lagi naman natin to ginagraph since midterm. So kilala nyo na yan. F of x is equal to 1 over x. When x is equal to 1, then it is here. So really connected talaga yung graph from the left and right. Mag-exist ang g of 1. G of 1 actually is defined, that is 1. And the limit of 1 over x as x approaches 1 from the right. Let's have plus here as a symbol. That still gives you 1. If you check left of it, left of limit of 1 over x as x approaches 1 from the left also gives you 1. Kaya nilagay dito, right and left continuous siya. Ngunit, makikita natin na hindi mo pwedeng daanan ng 0 because magiging undefined siya at x that is equal to 0. Okay? So you have to take a look into ano yung dahilan pagiging undefined niya dahil dun mag-i-stop yung pag-move ng graph. Because x that is equal to 0 becomes the vertical asymptote of that. Okay? Now, sa madaling salita, kailangan mong obserbahan muna yung domain and then you have to take a look into satisfy the two conditions here. Now, to sum them up, we have the continuity on an interval, 9 conditions here. We can say that the function f is said to be continuous Okay, we have the following conditions. Una, everywhere. So kahit ano daw, kahit saan, anumang interval ay continuous siya. Okay? Kung ang f ay continuous at every real number. Kailan ito totoo? We can have here the cosine function, the sine function, polynomial functions. We can also have the exponential functions kasi lahat tatanggapin niya ng inputs mo. Okay? So continuous siya kahit saan doon. It is continuous on the interval, no, between A to B if f is continuous at every point x at A to B. Continuous din siya on. No, take note of this term on. On the interval from A to B if f is continuous on, okay, interval between A to B and from the right of A. Right of A. Okay? And tong pang-apat naman from the left of B naman ang patunayan. Okay? Tandaan niyo yung symbol na ito na included symbol. So kapag may mga included symbol, you have to check the right kapag ang inclusion ay nanggaling sa right, or check the left when that's on the left. Okay? Next, in number 5, from A to B, continuous siya dun kung mapapatunayan mo na ang f ay continuous din on the half-closed, no, interval. Okay, all numbers between A to B but include B, and on all numbers, no, from A to B. And the other also continuity on infinity naman ito. It is continuous on all numbers greater than A if mapapatunayan ulit that f is continuous at all x values greater than A. And number 7, that is continuous on all numbers greater than or equal to A if we can prove that it is continuous on all numbers greater than A and from the right of A. You see, you can have right of A ulit kasi nakikita natin ito included na symbol, half close. 8, we have here all numbers less than B, continuous siya dun if you can prove that all numbers x, no, is less, all number x is less than B. Okay, and nandito na naman ang symbol na included if you can prove that it is continuous on all numbers less than B but also from the left of B. Now to understand this, for I know that parang nakakalito, no? Kasi puro interval. I provided here 9 examples where you can immediately visualize kung anong sinasabi ng continuous at continuous everywhere. Polynomial function can also tell you it is continuous, no? Anumang polynomial function yan, lagi siyang continuous kahit anong interval. Take note of that. Even the absolute value function will accept all real numbers, domain niya. Continuous siya everywhere. The sine function, the cosine function as suggested kanina. Even the exponential functions are continuous everywhere. Ang radical function naman, you have to be very conscious, no? Continuous siya everywhere if the index is an odd number. Take note again that, well, cube root of -1 is not undefined. Hence, however, it is equal to -1. Rational functions are continuous on their respective domains. So you have to check the domain. Okay? So ang madalasan tinitingnan natin dito, the domain rule. Alamin mo muna yung domain at kung pasok ba doon yung hinahanap mong interval, ibig sabihin continuous siya doon. Kung may na-violate ka sa sinasabi ng domain, ay hindi totoo yung continuity doon sa interval. Yun ang sinasabi ng respective domains. And so with the logarithmic functions, we have the respective domains. Take note, logarithm is very sensitive, no? Because the logarithm of x to any base a, x do not accept all numbers. X should not be, no, should not be a number 0 and all numbers less than 0. Radical functions when n is an even is continuous only here on the interval greater than or equal to 0. Why? Because you can actually prove. Bakit nga ba ito ang continuous siya dito sa greater than or equal to 0? Kasi pwede mong patunayan ang f of a. F of a, patunayan mo yan. And when it comes to the limit of that function, as x approaches a from the right, kasi yun ang sinasabi ng, remember this included symbol? Okay, yun ang sinasabi ng rule number 3, you have to check the right of A. And when we check the right of A, that will always lead you to a number that is 0. So f of A is 0. Limit of f of x as x approaches A from the right is also 0. They are the same. So ibig sabihin, totoo nga, continuous siya on that interval. And in number 9, the greatest integer function accepts all real numbers on the interval. So we have here the interval here. All numbers greater than n, but less than n plus 1, where n is any integer. And again, these continuity rules, patuloy natin papag-uusapan ito as we move to the derivative functions. Now, let's say, for example, let's have two sample problems. Let's check if g of x that is equal to square root of x minus 1 is continuous at interval, let's say 3 to all numbers greater than 3. So pwede mo na kaagad, kayang-kaya mo na itong i-check. If you're going to have to substitute 3 here, g of 3, it will provide you square root of 3 minus 1, square root of 2. If you're going to use the limit process, limit of g of x, excuse me, as x approaches 3 from the right, bakit right? Okay, you can check the right here para makita natin kung pareho ba sila, equal ba sila. So we have here square root of 2 yung g of 3, limit of g of x as x approaches 3 from the right is also equal to square root of 2. Why? Because it just falls under easy limit kasi wala namang restriction sa mangyayari if we substitute 3. At the same time, we can say din that it is continuous on the interval 3, all numbers greater than 3. Why? It must be all numbers greater than or equal to 1. Bakit? If we check g of 1, g of 1 is equal to square root of 1 minus 1. That is 0. If you're going to get the limit of g of x as x approaches 1 from the right, that is also 0. Okay? Ang left ng x approaches 1 or ang left ng 1 ay magiging DNE. Bakit? Kasi walang graph on the left of 1. Because the domain of the square root of x minus 1 is a set of all real numbers greater than or equal to 1. And on the next video, let's talk about the types of discontinuities.